Welcome to another tutorial in the Pycify class. My name is Gabriel. Today we will be looking at operations which can be performed on strings, the data type string. In the last class we introduced variables, we talked about the data types. So in this class we'll be discussing the operations that you can perform with strings. The first kind of operation that we'll look at is string slice. Then we'll move on to talking about the basic operations that can be performed on string. And in this subtopic we'll discuss concatenation using the plus sign, and we'll also look at replication. We'll also look at replication using the multiplication sign. Then we'll go on to talk about membership operation. Here we'll use the reserved keyword not in and in. Then we'll move on to the last kind of operation. This is membership, sorry. We'll move on to the last operation. That is the replication. Here we are going to use less than, greater than, equal to, less than or equal to, greater than or equal to. So at the end of the class we must have discussed all these, and hopefully we are going to understand what we mean by all these. So let's start. Before we can discuss the string slice, we will need to talk about indexing in the Python language. Now, the index simply tells us the positions of different characters in a string. For instance, you have a string, say you have a string called tutorial. Now this string has its index count from 0, 1, 2, 3, 4, 5, 6, then 7. And this shows us that most programming languages, if not all programming languages, start their index count from 0. So T, as in the first T in tutorial, has its index position at 0. U has its index position at 1. T has its index position as 2. And just like that, we get to the last index, which is L, which has its own index position at 7. So, but you understand that the length of this string now is 8. That is, the number of characters we have in this string is actually 8. But when you are checking their index, since you are starting from position 0, you end up having 7 of those indexes. So the way you work with index is very simple. For instance, let's make a new word. Let's give a variable name, new word, and we assign it to Pythonic. Okay, in line 4 we created a variable, new name, and we assigned Pythonic to the new word. If we are going to print new word, we want to get the index position, we want to get the character at index position 0. All we need to do is use a square brace, then we'll put the index position we want, say 0, then close it and close the ending. So when I run this, you will see we have P printed on the screen. Now the P is actually the okay, let's see, this is Pythonic. So we have 0 1 2 3 4 5 6 7, right? So the P you can see printed on the console is because 0, the character at index position 0 is capital P. If we change this index position to 5, you will see that we will have N printed on the screen, that is N, showing you that the character at index position 5 is the N. So just like that, you can access all characters in this particular string. Like you can see in line 5 above, the indexing stopped at the 7th one. So if you put an index position that is not correct, Python will throw an error to you, telling you that it is an index error, meaning that you cannot access index positions that are not found in that particular string you are looking for. So meaning that the only values that can come in here is from 0 to 7. That is the only kind of value that can come in this position. Now this way of accessing string is actually, I'll call it the forward kind of forward, because there is also a way we can access string backward. Now the backward kind of assessment starts from the C you're seeing here will have its index position as -1, I is going to have -2, N -3, -4, -5, -6, -7, and -8. So I'll be having -8, -7, -6, -5, -4, -3, -2, -1. Okay, I'm going to have something like this, meaning that C has its own index position as -1, I has -2, N has -3, and just like that we can access every other index position here. So for instance, let's still try and fetch our P. The way we just do it is put the index position, this is backward, right? This is backward. This is backward. Okay, so when we put index position -8, we are going to be accessing the character at index position -8 using the backward kind of movement. So you can see we have P printed on our console, meaning that the character at index position -8 is actually a P, a capital P, and just like that we can access every other index. So but when we are going to talk about, since we are talking about string slicing, I needed you to understand what indexing was all about. So moving on to string slice, just like the name goes, you are slicing a string, and for this you need some parameters to be inside the square brace you have here, and the parameters are such: you have the beginning index, you have the ending index, then you have the step. The step has a default value of 1. So for instance, if I start at 0, which is my beginning index, and with a colon, I will now put the ending index, and I can have 5. If I check this, let's see what we have. So you will see we have Pytho, and the character we have, the string we have here is actually of length 5 minus 0. So you can see it here, this is Pytho, and you will notice that it printed 0, the character at index position 0, 1, 2, 3, and 4. Now it did not go on to print the character at index position 5, because that is how it actually works. The character at that ending index will not be displayed. Rather, the last character will be the character at just before the ending index, which is 4. Now more examples will show you what I mean. If I put index position 6 here, then we will have the whole Python printed onto the console, because since we've indicated that the index position is the last index position, or the ending index position is 6, and if you check through our forward movement, you will see that 6 is actually for I, but it is not going to print I to the console. Rather, it will print the character just before I, and the length of string will be the ending index minus the beginning index. So that is why we have a 6-letter word printed on the console. If I still indicate 4, now just like you would imagine, we will have on printed on the screen, meaning that 6 minus 4 is 2. That is, what we will have on our console will be a 2-letter word, and it is going to begin from 4. It now check the character at index position 4, which is O, and then the next character, which is N, but it won't print the character at index position 6, which is I. So that is why we just have ON printed on the screen. Both the forward and the backward kind of movement can be used for string slice. If we want to display Python using the string slice, all we need to do is use -8 to see, I think 3, right? -3. Yes, that should be it. -2, sorry, -2, because we want I to be printed on the screen, so we'll stop at -2. So now you can see we have Python printed on the screen. But when you are using the forward, you saw that we did from 0 to, for the backward we used the brace 0 to, and we stopped at 6. So that's what we actually did. But when you are using the forward, you start from -8 and then indicate where you want it to end. So that covers it for both the forward and the backward kind of movement. Then the last parameter that this can take is the step, and I told us that it has a default value of 1. So the last parameter is 1. And if we run this, I would like to use the forward kind of movement so that it will be clearer to all of us. This is 6, right? So you will still have Python in the forward kind of movement. And why you are getting Python here after indicating the third parameter is because the default value for this is 1. So it moves one step at a time. But if we put 2 here, now see what happens. We are going to have PTO printed on the screen, because Python is going to print the first index, then it will skip 2 characters and print the next one, and that is actually a T. And now it will skip the 2 characters again and print the next one, which is O. Now since our ending index is 6, it will stop printing. So the order for this, once you put a step, is it will start from 0, 2, 4, and if you have more words, it will just keep 6, just like that, 8, just like that. It will moving in that step. So if we have a 3 here, and we have 0 as our starting index and 6 let's put 8 as our ending index. So we are going to move in this order: 0, 3, 6. Now you will expect a 9, but since our word Pythonic is not up to index position 9, we are just going to have this printed on the screen. So if I run this now, we are going to see that we have PHI, and that is actually the character at index position 0, the character at index position 3, and then the character at index position 6. That is how Python does its own kind of string slice. Also, if you do not indicate the starting index, you leave it empty and run, you will still get the same output, because the starting index has a default position of 0. So if you do not indicate the starting in position, just like we did not indicate the step, which has a default value of 1, you will see that we will have the same thing printed on the screen. Also, if you do not indicate the end position, you have the same thing. So Python will just assume that it will just take the beginning of the string as the beginning index, and then the length of the string as the end index. So that is what Python will do. It will put default to 0 for the beginning index, then the length of the string will be the default of the ending index, then the step will still be the same. And there is a special kind of step of -1. When you indicate that your step is -1, it's actually moving in the reverse order. See what we have printed on the console. You see we have CINOHTYP. If you look at this closely, you will see that this is actually the reverse of this word Pythonic. So when you put a step of -1, Python will switch the word. It will write it from back to front. So that is a special kind of, maybe you are asked to return the backward, that is, you're asked to write a word from back to front. You can simply use string slice and put a step of -1 and you get the job done. So the next thing we'll be talking about is the basic kind of operation. And here we said we are looking at the first one, which is concatenation. The first one, which is concatenation. Now, concatenation on its own simply means joining. When you say you've concatenated two things, what you're actually saying is that you have joined two things together. So if, for instance, we print this, you print the word Gabe, okay, you have Gabe, and then you have another word, RIEL. When you print this, you see that I have Gabriel printed on the console. What this actually did was it printed the word Gabriel, then joined it with the word RIEL. So it printed the word Gabe and joined it with the RIEL. So kind of concatenation, and that is why we have Gabriel on the console. Now understand that this is very different from doing Gabe with a comma and having another RIEL. They are very different from each other. Now you will see that the first one will actually concatenate Gabriel, and then here we have Gabe as a word with a space, and then we have RIEL. So both kind of operation, that is the operation on line 4 and the operation on line 5, are not the same, and you should know that. Okay, you should also observe that even it does not matter the kind of spacing I give in between. If I still execute this, you see I have Gabriel printed on the console. But when we are talking about concatenation generally, I would like us to make use of the addition sign. That is, use a plus in between what we want to concatenate, and this is the standard for string concatenation. When you use a plus here, then you can still indicate a plus, and then you have tutor. Okay, this is tutor. When you do this, you actually have Gabriel's tutor. That is, this shows you that you can concatenate more than two strings. Okay, we have Gabe concatenated with RIEL. Then you also have another concatenation with a space and then tutor. If you do not want to do this like this, let's do something like this. So if you don't want to do this like this, you can as well concatenate this way. You have Gabriel. Okay, then you are concatenating with an empty string, and then you are performing another concatenation with the word tutor. Okay, so you will see that the two of them will give us the same output, Gabriel and tutor. So but the way we concatenated are not the same, and that is why you need to understand how concatenation works, so that when you are faced with a particular problem, you will know the best kind of concatenation or the best way to solve the problem. You should also see that this will give us exactly the same output. Okay, this will give us the same output. You're having the three of them give Gabriel tutor, just the same way. So you should understand this, and then you will know the best kind of way you can use your concatenation. But remember, the line of code on line 6, that is what I have here, the highlighted line 6, is not concatenation. We'll still talk about this comma and how it does its own operation, but you should know that it is not a concatenation procedure. The only two concatenation we did here was the one on line 4 and the one on line 5. So that is concatenation. Another important thing to note is that we cannot concatenate a string and any other data type. So when you try to concatenate a string with an integer, you will have an error. Now you can see we have a type error telling you that you can only concatenate string, not int. So this means that any other data type, both the list, the tuple, the dictionary, and all of them, can't be concatenated with string. Concatenation can only be done with two or more strings. Okay, then we'll move over to the next one, which is replication. So we have replication. Now the replication uses the multiplication sign to perform its own operation. Imagine you are given a task to print man. Alright, you are given a task to print man to the console 4 times. You have man, and you keep repeating the man. But that is what concatenation would have handled effectively. All you need to do is write the string, then indicate you put the multiplication sign, then indicate the number of times you want it to be replicated. Let's copy this. Okay, let's see this. You will see that the two outputs will be the same. So you have man, and man, meaning that this particular code on line 4 can actually be done the same way in line 5, and that is the power of replication. But there are two syntaxes to replication. Either you indicate the multiplication in front or you indicate at the back. Both works just the same way. So you will see we have man, printed on the console. And another thing to note is that you cannot concatenate you cannot replicate with any other data type if not a string and an integer. If you try to replicate a string and a string, say boy, okay, let's see, if you try to replicate a string and a string, you have an error. You are getting a type error, and you can't multiply sequence of non-int. You can see, so replication has to do with a string and an integer, or an integer and a string. Both works just the same way. Now, something you should know in both concatenation and replication is that if you use addition on two strings, okay, if you use the addition on two strings and use multiplication on two integers, if you use addition on two integers and use multiplication on two integers, your output will just be the addition of those two numbers and the multiplication of those two numbers. So that is why the replication, that is the addition and the multiplication, in terms of concatenation and replication, only works on strings. You can't use it on any other data type. It's either you get an error or you won't get the expected output. And that covers it for basic operation. The next kind of operation we'll discuss is the membership operation. Now, membership operation is used to check if a string is a subset of another string. That is, it checks whether a particular string can be found in another string. When it checks and see that that string can be found, it returns true. But if it does not find that string, it goes on to return false. True just says that the statement we made is true, while false says that the statement we made is not true. I will explain with an example. You have a word, say Python, okay, and you want to check whether it is in the word Pythonic. Okay, you can see we have Python, and you are checking whether this Python as a word or as a string is inside the string Pythonic. When you run this, you'll see true, meaning that the word Python is inside the word Pythonic. Okay, I think this will be better off when we do it with a variable so that we can move around. Okay, we have new word variable, so this new word is set to Pythonic. All right, so this will give us the same kind of output. Oh, sorry, this should be a string. This should be a string. So we have true printed on the console because Python as a string is in the word Pythonic. So we have true printed on the console, and that is how membership operation works. You can check using not in. When you use not in and the statement is false, it will return false. That is, if the statement you just made is not true, it will return false. But when the statement is true, it is going to return true. Now on line 4, I said Python not in new word. That is actually false. So I will have false printed on the console. Okay, but look at what happens when we check whether Python with a small letter P is in the word Pythonic. You see we have false. Okay, I checked whether Python as a beginning with a small letter P is in Pythonic, and it gave false, meaning that Python with small letter P is not in the word Pythonic with capital letter P. So that goes on to tell you that that the small letter P is not equal to P. Okay, and now I said that the capital letter P and the small letter p are different. So once Python sees something that is not that is not in the word you are checking, it will return false. But if I delete this and just have HON, you will see that we have true printed on the console because HON is actually in the word Pythonic. But what if I put HCN? Let's see what we have. Now you are seeing false. Excuse me. You are seeing false on the console because though H is in the word Pythonic, C is also in the word Pythonic, N is also in the word Pythonic, but we have false printed on the console because Python does not check each of the word one after the other. It collects this word as a group and try to see if it can find that word as a group in the universal set. Let me put it that way, in the universal set. Okay, our universal set is a new word, right? So Python will check whether the HCN can be found just like that, HCN anyway. You can see that if I replace this with a C, okay, I replace my O with a C and run this, you can see I have true printed on the console because Python has seen that HCN as a group of words is actually in this particular new word, and that is why I have true printed on the console. If you make relations, you try to relate with not in, and your logic is correct, you have false. You are going to get false because HCN not in new word is a false statement, and that is why we have false printed on the console. Okay, so the membership kind of operation takes the string as a group of word and checks if that particular string is in the word you are looking for. You can also check for characters, say an O. Now you can see that I do not have O in this new word. So if I run this, I should be getting true because O is not in new word. But if I replace this C with the initial O I had, you can see that this is a false because O not in new word is a false statement, and that is why we have false printed on the console. The last kind of operation we'll talk about is the relational kind of operation. Okay, we have that is the relational. In the relational kind of operation, Python tries to compare. It deals with comparison. Python just compares two strings, and after the comparison, it will check your logic and give you the output. Either it will throw a false or a true. So relational has to do with comparison, but membership is all about checking whether a string is a subset to another string, and that is different from membership, which does its own check with comparison. I will demonstrate with an example so that it will be clear. And if you can remember, I told us that the symbols that we use for this operation is the less than sign, the greater than sign, the equal sign, equal to sign, the less than equal to sign. Okay, the less than or equal to sign. Then we have the greater than or equal to sign, and then we have the not equal to sign. So these 6 symbols are what we use for comparison. So now on line 5, I printed I checked whether apple is equal to the word apple. Now this apple is on the left hand side, and I'm checking whether it is equal to the word apple. Let's see what it will give us. Okay, we have true, because apple on the left hand side is actually equal to the word apple on the right hand side, and that is why we have true printed on the console. One thing to note is that Python does this check using the ASCII standard. That is the American standard for code information interchange. Yeah, American standard for code information interchange. That's the standard the comparison of the relational operation rather uses to check its own comparison. Okay, let's see another example. We have apple. We are trying to check if the word apple is on with a capital letter A is equal to the word apple. Let's see. Now you are getting false because the word apple is not equal to the word apple. When you want to use not equal to, you can just with an exclamation mark and an equal sign, you have apple. So this is a kind of way of saying apple with a capital letter A is not equal to apple with a small letter a, and that is true. So you can also check for greater than, less than, and all those. Let's see, you have greater than, so you have false. Now I checked whether the word apple with a capital letter A is greater than the word apple with a small letter a, and I have false. Okay, I will explain why this gave us a false using a built-in Python function called ordinal. We use ORD. Okay, this will better explain what we are talking about. Now you can see when I ran the ordinal for capital letter A, I had 65, and when I checked the ordinal for small letter a, I had 97. So when someone is trying to check if small letter a is greater than capital letter A, okay, I checked whether small letter a is greater than capital letter A. So what Python, and it gave a true. But how Python did this was it checked the ordinal value for small letter a, and it saw that it was 97. Then checked the ordinal value for capital letter A, and then it is 65. Next thing it will do is to check whether 97 is greater than 65. So this comparison is actually one of comparing integers and not strings, because what Python is actually comparing here is the ordinal value for small letter a and the ordinal value for capital letter A. So you can imagine that what you are saying is the ordinal value for small letter a is greater than the ordinal value for capital letter A. This is what you would imagine it as. That is, you are asking whether 97 is greater than 65. That is simply what Python is checking. It is not seeing this small letter a as small letter a. Rather, it is seeing it in terms of its ordinal value. And we are checking if 97 is greater than 65. Now that is true. So that is why we have true printed on the console. The way it does this, okay, let's see something. I have a file I saved. Okay, this is actually a code I wrote to better explain this. Now when I run this particular code, now let's see. Okay, you can see here that I checked all the ordinal values from A to Z, and you can see that it started from 97 for the small letter A. You have 98 down to small letter Z. That is what you have here. So the last one is Z, and it is the small letter Z, which has an ordinal value of 122. Then I checked the ordinal value for capital letter A down to the last one, Z, and its ordinal value is actually 90. Don't concentrate on this line of code. I just used it for explanation purpose. So if you can look at it, so whenever you are comparing strings, what you are actually checking, for instance, if you are comparing whether x is greater than b, you have true printed because 120, which is the ordinal value for small letter x, is bigger than 66, which is the ordinal value for capital letter B. So that is why, see, let's see, if you print x greater than capital letter B, you can see we have true down here because x has a value of I see 120 and B has a value of 66. So Python will go on to check whether 122 is greater than 66, and it will see that it is true, and then we will have true displayed on the console. For words that not just characters, let's say you have a word ball, we have ball here, and then you have ball here. Okay, rather let me make this a small letter and make this a capital letter, because true always explains this better in my years of experience. Let's see, I checked whether ball with a small letter B is greater than ball with a capital letter B. Okay, now the way Python does this is very simple. Python does not go on to check the ordinal value for everything here, no, or check the ordinal value for BALL, no. It just checks the ordinal value for the first character on the left hand side and checks the ordinal value for the first character on the right hand side. Once they are not the same, it will print out it will now return what the check is. Now look at what I mean. Python checked the ordinal value for small letter B and checked the ordinal value for capital letter B, and since all small letters are greater than all capital letters in terms of ordinal value, it printed true because small letter B is greater than capital letter B. Now anything that comes after it, that is the ALL, does not get executed. Once it has seen its own the comparison, it stops its check and returns true or false. Okay, now let's see, if you have B with a small letter and you have A with a capital letter, and let's understand how Python does this. Now Python will check the B on the left hand side and the B on the right hand side, and it will see that the both of them have the same ordinal value, right? They have the same ordinal value, so Python will not display, it will not return anything, and it will go on to check the next ordinal value. So the ordinal value for small letter A on the left hand side is actually greater than the ordinal value for capital letter A on the right hand side. So that is why we have true displayed on the console. The remaining LL does not get executed by Python because it has found the comparison it is looking for. Just that way of going line by line or character by character between these strings, then it will get the output it is looking for and stop execution. So when you have ball and ball, it's simply the same thing as checking B, as checking ALL and ALL with a capital letter A. It's simply the same thing because the B we had prefix to the A are the same, so Python does not check that particular B. So when you run this, you can see that we have the same output, true. That is, A and A are not the same ordinal value. So Python will now check their ordinal values and return either true or false. Okay, so the other kind of comparison works just the same way. If we use equal to sign here, you will see false, because Python has checked whether this capital letter A is equal to this small letter A is equal to the capital letter A here, and it is false. So Python will just display false. Now, something else you should know is when I have B as in small letter B and another B as in small letter B. Now, some persons will want this to print true because the small letter B here and the small letter B here are the same, so it should print true. No, Python would not work like that. It will go on to check the next character, which is A, and the next character, which is A. So when it sees that the next character A and A are of different ordinal values, then it will print a false. So you can see that the way it checks the greater than sign and the way it works for equality sign, okay, that is the equal to sign, is not exactly the same. So that is why you are having this. So once it checks B and B and it sees that they are the same, it will go on to check for the next two characters. Now it will see that they are different, meaning that this particular statement is wrong. That is why we have the output false returned on the screen to us. So if you can understand how the greater than, the less than, the equal to sign, the greater than equal, the not equal to sign, then you are good to go in your relational operation. So let's have a recap of all we did. Firstly, we started by explaining index. We went on to talk about string slice, then we discussed the basic operations that are in Python, and we said we are using the concatenation and the replication. Then we went on to discuss the membership kind of operation, and here we said we use Python reserve keyword not in and the in. Okay, then the last one we talked about was the relational kind of operation, where we said we use the symbols less than, greater than, less than, equal to, greater than, equal to, and not equal to. So these covered most of the operations we have on string. Okay, now thank you very much for this class. More tutorials on other data types will come up soon, so just go through these ones and understand. Remember to like the video and hit that subscribe button. Thank you. I remain your tutor, Gabriel from Pycify. Thank you.